Now that we've graphed an ellipse, we're going to work backwards and write the equation based on a given graph. This is also going to help us see how all the values really work together to give us some pretty important information as we work. We're going to start with the center just like we did when we were graphing, and we know that's from h and k, and that h and k in our formula come from inside the parentheses with x and y. So I need to find this graph. It's pretty obviously centered at the origin. If it wasn't, then we would be looking for the very middle, and the way we find the middle, or the easiest way to find that center point, is to kind of look at where we could fold it, or where it looks like there are lines of symmetry. And when I lightly sketch those, they intersect at the center. So that reinforces what we thought it looked like to begin with. So I know the center is at 0, 0, and I'm going to drop those back in to parentheses. Okay. Once we've got that information, we're going to move down. The next thing in our list is our A value, which is half of our major axis. Remember, major is the long one. Since it's a horizontally oriented ellipse, I'm going to look from side to side. If I count all the way across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I know my major axis is 14 units long, and it's 7 in each direction from the center, which is my A value. It's horizontal, so I know that that's going to go under the x in my equation. And that 2 is already there as an exponent to remind us that when we simplify, we need to square that value. I can also go ahead and write down the vertices. Remember, just like a parabola, it looks like it turns around there. And that's what's happening in your ellipse. It happens twice. The vertices are the endpoints of the major axis. So I'm just going to go grab those ordered pairs and write them down. 7 from 0, -7, and 7 in the other direction, the ordered pairs. If we were centered somewhere other than the origin, we'd just be looking for the specific coordinate. These are particularly simple because we are centered there. All of that information just from the A value and the minor, or the major axis. So next we'll look at B, which comes from our minor axis, the shorter one. If I count all the way across, 1, 2, 3, 4, 5, 6. The length of the minor axis is 6. Half of that is 3. And if we look back, I know that 1, 2, 3, again, we're reinforcing the center. And that's our B value. It was in a vertical direction, so we're going to put that underneath Y in our formula. It does change directions here as well. The minor axis, we call those the co-vertices. It's a similar property, same thing is happening. It stops increasing towards the right, begins decreasing. As we come back around, it's decreasing, and then it starts increasing. It's a change of direction. So I'm going to pull those ordered pairs as well. Those are at 0, 3, and 0, -3. Okay. So the only thing we didn't address when we graphed it is this C value and this word that is foci. It's the focus points. A circle has just one, and it's the center. But from our picture at the top of the page, we talk about if you stretch that center apart, break it into 2 pieces and pull it. Think about putting your fingers in a rubber band and pulling it sideways. That's going to make our circle flatten out and become an ellipse. We can calculate C based on our A and B values, and if you've forgotten which one is which, it doesn't really matter. You're just going to subtract the larger from the smaller. So if I have 7 squared minus 3 squared equals C squared, I know 49 minus 9 equals C squared, 40, and so C equals the square root of 40. Which is not a perfect square. It's going to be an irrational answer. We can estimate it, right? I know the square root of 36 is 6, and I know the square root of 49 is 7. The square root of 40 is going to be somewhere in between 6 and 7. 40 is closer to 36 than it is to 49, so we want to be closer than halfway, say about 6.3. And when I go to plot that from the center, if I plot in the wrong direction, 1, 2, 3, 4, 5, 6.3, it's not inside the ellipse anymore. So that should help you remember to plot along the major axis. 1, 2, 3, 4, 5, 6.3-ish. There's a focus. And the other one going back the other way. And to write exact ordered pairs, we're going to track what we did. I started at 0 and went to the right, the square root of 40 units, and up 0. And we started at 0, went to the left, the square root of 40 units, up 0. Those are my ordered pairs. Okay? We've filled in everything we need to fill in. All we need to do is simplify and clean up our formula. X minus 0 squared can just be written as x squared. 7 squared is 49. Plus y minus 0 is just y squared. 3 squared is 9, equal to 1. Don't forget about the plus and the 1. Those are important. They never change. They are signifiers of an ellipse. And we are finished with the second example.